Welcome, everyone. I'm Pat Swazi. I'm president of the Federation of Vermont Lakes and Ponds, and I want to welcome you to the second in our Clean Water Projects webinar series. This one, as you can see, is how to assess your lake's water quality data with Mark Mitchell. Before we get started, I just want to mention that it is January, so we are reminding people about membership. We really rely on our members, both our individual members and our association members, to make these kinds of events possible and to support all of our other outreach, education, and advocacy projects and all of the work that the Federation does for you and for our lakes. So just a reminder, if you haven't yet sent in your membership for 2025, this is a great time to do it. And if you are part of a lake association, you can check in with your association and make sure they send in their membership. We're urging you to do that this month. So just a reminder, we can't do any of this work without you. So we really appreciate all that you do, and we appreciate your support. Okay, so moving on. Again, welcome to our second episode of our webinar, Clean Water Project webinar series. Just a couple of housekeeping things. We are recording this, and we will post it on our YouTube channel and our website in a few days or next week probably. So not too long after this is done, you'll be able to access it there. We ask you to stay muted while Mark is presenting, and if you have comments or questions, you can put those in the chat while he's speaking, and then we'll do questions and answers and discussion after he does his presentation. If you, at that point, you'll be asked to unmute, and then you can ask your question, or you can just put it in the chat because we have people monitoring the chat. Okay, and without further ado, I want to introduce Mark and welcome Mark Mitchell to this. Many of you know Mark, I'm sure. Mark is a limnologist, and he's also the lay monitoring lead and the lake assessment coordinator in the Vermont DEC Lakes and Ponds program. So with that, I'm going to turn it over to Mark, and welcome, Mark.
Great, thank you. Thanks for everybody joining this webinar. Pretty happy to share information today so everybody can kind of access the data that the lake monitoring program collects and the different kinds of reports that we put out there. I just finished doing some updates for this previous year of monitoring some new reports. So, share my screen here. So it looks like I'm not able to share my screen at the moment. For where permission can be given. I'm just going to pop up that says host disabled participant screen sharing.
I had you set up. You should be able to share. Let me just double check. Okay, should be okay now. Here we go.
Presentation mode. Okay, great. So, yeah, I think you had the introduction already. So today I'm going to be presenting the Vermont Lake Monitoring Program, kind of going to the website. And just want to mention that my position is actually a partnership between Vermont DEC Lakes and Ponds program and the Lake Champlain Sea Grant through UVM. So I'm actually technically a University of Vermont employee at the moment, but it's a pretty good partnership. Keeps me employed as well so far. So yeah, just kind of going through the agenda today. Basically, gonna take everybody on a tour of the Lake Monitoring Program website. I made this slide presentation, kind of doing screenshots of the website, so we can kind of follow step by step, and I can share this with everyone afterwards. But it really is just going through the actual website itself and the different links that I have set up there. So the idea is to show how lake associations can, let's minimize that, access and use the new lake monitoring program data and reports that I mentioned. I just did some updating in the last couple of years. We're going to explore some of that information and condition at a specific lake and compare it to other lakes. So that's kind of looking at lake reports for a specific lake, and I'll use an example for that. And then, yeah, with those examples, we'll be given on how the data can be used to support clean water projects, so like lake watershed action plans, which we have about a dozen or so lakes, probably actually up to about 15 lakes now that have these watershed action plans. And also other things like, lake management, like alum treatments, which we just did one recently on Lake Maury, but actually the second time. That was this past summer. So using some of the data, the monitoring data to kind of show before and after effects, and also to inform those alum treatments for permitting. So Lake Carmine is kind of next up with that the next year or so. That's sort of the kind of a restricted sort of lake management that we do only in the most severe cases. But yeah, just showing how this volunteer data as well as other data that we collect informs those management decisions. Then finally, we'll have a discussion which will include how to best communicate this available data, which is mainly, from my point of view, sharing these lake-specific and comparison reports on Lake Association websites or other websites from the towns. We're really just kind of using these links, what I have set up on the webpage. I think it's probably one of the best ways. And this is just a map of the current lake monitoring program lake sites around the state, which is pretty good coverage at this point, actually kind of reaching capacity just logistically and also with lab budgets. Specifically this coming year, we're having quite a large increase in lab budgets, lab costs, I should say, for parameters, and I'll get a little bit more into that. I'll mention that again later on. So first thing to do is just, kind of going straight to the lake monitoring program web page. And so I include all the web addresses up here on the top. And you can actually just Google Vermont Lake Monitoring Program, and this will be the first thing that comes up. So at the top of the page, it just kind of goes through the main goals of the program, which really haven't changed much. It's establishing baseline water quality conditions in Vermont lakes during the summer recreation season. We're really looking to track long-term nutrient trends and eutrophication of Vermont lakes, and assessing that data compliance with the Vermont water quality standards. And that's something that's been the water quality standards are updated every so often. So now the lake monitoring program is actually kind of fits right into the water quality standards, especially for nutrient criteria. So that's kind of where that criteria came from, was the actual volunteer data over this long period of data collection. And then finally, to educate lakeshore homeowners and lake users about lake ecology and stewardship. In total, we've had over 100 inland lakes and at one point over 40 Lake Champlain stations in the program. We've kind of focused more on inland lakes now and reduced the number of Lake Champlain stations to just a few of the bays that our own staff or staff from New York aren't collecting monitoring data from. And now we have close to like 90 inland lakes around the state being monitored. So that's really great to kind of have that coverage, because it really is one of our best long-term monitoring programs, certainly for the amount of lakes that we're actually monitoring. So scrolling down from there, there's a set of quick links here, and this is really kind of the main, base that I use anyways to access different information on the web page. And so the rest of the presentation, I'm going to kind of go through each of these quick links to show you what information is there and how to access the reports and data, which is a little bit further down here. So it's what we monitor and why, And I'll try to breeze through some of these first things so that we have time to go through the lake reports and data, since I think that's kind of the most important thing. But yeah, some background information here, and then there's protocols, monitoring forums, the web forum that we have now, and then the lake reports. There's this map of the lake sites, which will really make it a little bit more interactive, potentially having live disk readings posted there. And then how to actually download all the data as well. Some other information like lakeshore land use maps, which are pretty handy. And then other volunteer monitoring resources. And there's also a couple of links here that I recently put up for reporting lake ice out and lake ice in, which some of you have already been using. This is Survey 123 form. It's pretty handy that I actually make a web map from that as well that actually shows the live reports as they come in, which sometimes have to be quality assured for where those locations actually are. But yeah, these are really kind of the main links that you want to be using on the web page. So the first one is what we monitor and why, and the main parameters are down here. So water clarity using the SecuDisc, which I think most of you are familiar with. And now we're using SecuDisc with ViewScopes to make it a bit more accurate and consistent between volunteers. But we still are collecting data without the ViewScope as well to kind of have comparisons to previous data. Total phosphorus being the main nutrient that fuels algae and cyanobacteria, as well as aquatic plants. And then chlorophyll A, which is that representation of algae and cyanobacteria in the water, being the main green pigment in plants as well. And more recently, I've added caffeine to the list of parameters that volunteers are monitoring. And that's in the last couple of years with this past year where we've actually had the lab be able to test caffeine at a much lower detection limit, which has resulted in quite a few more results that we're able to report out on. And the idea behind caffeine is that it's a pretty good indicator of pollution from domestic wastewater sources. You know, the main one that we're concerned with on lakes of Vermont is from septic systems. So trying to get at, get a question. There's lots of questions about what are the impacts of aging, potentially failing septic systems on our lakes. We don't have really many regulations to track that unless you build a new home or expand your home around a lake. And caffeine has been used in other studies around the world, especially in river systems where there's wastewater treatment plants, but also in lakes to detect, potential inputs from those septic systems. Because since really caffeine can only come from human wastewater, for the most part, especially in this part of the world. So if we are detecting it, it's a good indication that there's probably some poor septic systems, or outdated systems, or potentially even failing systems around the lake. So scrolling down from there, just gets a little bit more into detail about the parameters that we collect and how we use that to assess our lakes using Vermont water quality standards. And then additionally, myself and other staff have been collecting chloride when we go out to visit lakes or do trainings. And we are seeing increases in chloride around the state in rivers, as well as, Lake Champlain, but other small lakes too, where typically wouldn't have any detection. It should be pretty low for the natural background around the state, but we're seeing increases. So we are tracking that as well. That's mostly from road salts, for ice, de-icing roads, but as well as like dust suppression we can use in the summer. So something to keep an eye on. And then there's a few links down here about lake ecology in general, if you want to kind of understand a bit more about things like stratification, thermal stratification, shallow lakes and how they kind of differ. There's a nice link there. And then lake watershed action plans. We have some new plans that have just been recently finished that are posted up there. And then restoring Vermont's waters, and that's for lakes that are actually impaired, which thankfully there aren't very many, including Lake Champlain, but also Lake Carmi and Lake Morey. So lakes where we're doing, more management on, like an alum treatment. Tickle Naked Ponds in there too, which is first and only lake that we've taken off the impaired list because it did have an alum treatment about 10 years ago. So there's a lot of information and monitoring data on those web pages. So just kind of how you can help or get involved, you can always contact me. As I was mentioning, we're kind of reaching capacity for the program at the moment. And that's kind of probably more from budget constraints, but also from just logistical challenges to get all around the state, get the samples to the lab in time. And also, you can report cyanobacteria blooms, so that's, anybody can do that anytime. There's a direct link to the form here. There's also the map, the tracker map the Department of Health kind of manages in collaboration with us and some other organizations. And there's some information if you want to train to become a monitor for that. There's also Lake Scorecard links here, background information on that, Lake Shores, Lake Wise, Vermont Septic Smart if you're interested in doing some sort of a septic social event, kind of connecting with our on-site wastewater program. And then you can also report environmental violations if you see anything that doesn't look right, and you can do it anonymously as well. So just another link to information there. And then, coming down to the sampling protocols, you can find all that information here. I recently just updated the protocols, sample labeling. So some of those things have changed over the years just to have more formalized, more standardized methods for people to follow. And then there's a link to the web forum again for submitting your SEPI data and also some water sampling information for the volunteers. And another link to our water quality data portal. You can actually find the sampling site location info here. That's a latitudes and longitudes, and also direct links to Google Maps that'll drop the site location right there. Depth maps of Vermont lakes and ponds, which we've done some updating over the years. There's definitely still some outdated maps out there, but something we're trying to work on. And then the old field forms that volunteers can use in the field. And then finally, a quality assurance project plan, which is required by the EPA, so we can actually use that data, the monitoring data, for assessments and also upload into their EPA water quality database.
Mark, this is Jackie.
Yeah.
Sorry to bother you, but someone said that they're having a little bit of difficulty hearing you speak, and didn't know if you could either speak a little louder. Okay.
Sure. Hopefully no one else is having the same issue. Try to sit a little bit closer to the computer. Hopefully that helps. So the next thing is this is just a quick demonstration of the web form. I just wanted to show kind of how it works now, because that's been updated over the years using Survey 123 at the moment. So it takes you to this page, which you can open just in your regular internet browser, or you can have the app on your phone, so you can actually collect and submit that data when you're out in the field, but you don't have to have the app. And basically what it looks like is just, this is the first page of it, but kind of takes you to the beginning of the forms, just like the same information that we used to have. I've done a little bit of updating, but it's pretty easy to fill out. There's a few different pages you just kind of go through, and the starred sections are the required sections. And then the lake reports is kind of the next section. This is what I'm going to dive a bit deeper into in a moment here, but this also has a link to Lake Scorecard and Next Generation Lake Assessment Reports, and that's another type of monitoring program that Kelly Merrill leads during the summer. And those are kind of one-off, I don't want to say sporadic, but it happens. They do these studies every once in a while in certain lakes, so there's more information there you can find. And then there's the other links to like the Lake Champlain monitoring program, the La Rosa Partnership Program, which does tributary monitoring. We've incorporated more lake tributary monitoring in the past several years. So kind of collaborating with that program as well, where we're having issues or we're wanting more data on what's coming into our lakes. There's also plant lists and fish lists that might be a little bit outdated, but those kind of the best information we have for what's in the lakes based on surveys that were done in the past. Then next again is this interactive lake site map, which eventually I hope to get SEPI depth measurements there during the summer. This is kind of what the list of lake reports looks like. It's the alphabetical list of all the lakes currently or recently in the program. And then East Lake has a link to its lake monitoring report directly. And then there's these comparison reports based on the different parameters, so you can see how your lake compares to other lakes in the program or in the state. And then a link directly to the lake scorecard, water quality monitoring reports, which look at trend analyses, status for our water quality standards. And that hasn't been updated since 2022, and that's partially because Leslie Matthews has kind of run those reports, and she retired recently. She did come back as a part-time employee, and so hopefully to help out with kind of transitioning those reports into the future. Ryan Walquist was also recently hired as a sort of monitoring supervisor and kind of replaced some of the work that Leslie was doing before. So hopefully we'll get that updated in the next year or so. And that'll have to reflect some of the new protocols in the lake monitoring program as well. And then there's other links to these kind of reports or data visualizations, graphs, things like that. So these are profiles that I take when I come out to lakes, do sampling visits, vertical water quality profiles of things like dissolved oxygen, temperature and pH, things like that, which I'll show you in a few minutes. There's also, I have, if I've done presentations or, larger reports for, let's say, Lake Maury, because of the alum treatment, I put those reports on here too. Then Lake Champlain has their reports as well. It's a little bit different. It's a lake scorecard. Trends haven't really been quite as updated for those stations. A little difference, but I do have links to the old lake scorecard reports here. And then you can also do comparisons. And this is sort of the remaining bays that we're monitoring at the moment. And there's also some weather resources here to kind of, if you want to compare from year to year, try to get some more background information of why, water quality was a certain way in a certain year. This is a good way to look at it. And I actually have been putting up some updated maps just below here for precipitation out of Montpelier, just as kind of a state representation. You can really see this increasing trend. This is summer precipitation, June through August. Since the beginning of the program, 1979, we're seeing sort of an average of 5 additional inches of rain during the summer period. And then looking at air temperature in Burlington, the same increasing trend from it's about a 4-degree increase or so during the summer air temperature. So, that's leading to potential water quality issues in our lakes. Obviously, the floods that we've had the last couple of years, that's picked up in this precipitation map too, which can definitely increase phosphorus loads to the lakes and reduce clarity, which we do see quite a few lakes during those times. So I'm just going to go into some of the lake reports. I'm using this one example for Lake Iroquois. And that's because it has a good representation of the different parameters that we collect and good results to kind of show in comparison to other lakes around the state. And it also has been involved on the ROSA partnership program for tributary monitoring and has a lake watershed action plan on it. So it kind of has just a bit of everything. So when you click on that lake monitoring report, this is what it brings you to. And up here, you can see the report year, which you can actually change, type in the new year, and then you always need to click on view report to see that year. And this is the lake monitoring ID, so you can actually change it directly from here, which is a 5-letter code. And then stations as well. So station 1 is a default, and that's the most centralized station using the lake where we're collecting most of the water quality data. Additional stations on lakes might have some SECI information in the past, so you can change that station number here. And a few lakes actually sample or they do SECI depth monitoring at a different station that's a bit more representative of the lake. And then there's some background physical information on the lakes up here for the watershed size, which you can see in the map over here in the location. And then kind of depth, maximum depth, which is pretty important for monitoring. And then the first bit of information for the monitoring data that you see is this summary table for the year. And it has a list of all the different parameters. And also I've updated this a little bit. So it's total samples, which now should be 6 samples for everybody, which is bi-weekly sampling or twice a month from June through August. So that we're standardizing that for each lake for better comparisons. And I've added this column recently too, which is samples below detection limit. And that was mainly because for the caffeine sampling, for the most part, most of the samples are below detection. And so I wanted to indicate when that happens because there is sort of a limit that can be reported out, and we'll say like a less than. But in the case of caffeine, it's 0.1. So we have like results that might say 0.1, but that's really the start of where detections happen. So we'll see that in the graphs. I'll show it a little bit. But also for phosphorus, the minimum detection is 5 micrograms per liter. And chlorophyll is 0.5. So we do have some below detection results as well. And I think I'll just go right into the graphs to kind of explain things a little bit more. It's from that table. So for Secchi transparency monitoring, Secchi disk monitoring, we have this with and without the view scope, as I mentioned before, which is kind of a nice comparison. It's a pretty tight comparison here for Lake Iroquois, but other lakes you might see a bit more separation. And that just depends on lake conditions, lake depth, as well as the volunteers themselves. But here you can see actually a big dip in clarity right in the July floods. And again, that was kind of a common observation that we saw, and then a rebound sometime after that. And then going down to chlorophyll, which is the next thing, sorry. So now with the new protocols, we have like all the lakes that are collecting water samples are doing an epilimnetic or surface water sample. And that's representing that epilimnetic layer of the lake, which is the top layer, the warmest water when you have thermal stratification in the summer. Or if the lake is just so shallow where it continually mixes, it's that upper surface layer. So lakes like Lake Iroquois have about 30 or so lakes now collecting additional deep water samples or hypolimnetic samples. So that's that bottom cold layer of the lake that gets separated during the summer. And that's, I focus most of those lakes to be sampling because, there might be different phosphorus concentrations or chlorophyll algae concentrations at the bottom of the lake. And a lot of that's fueled from sediments, especially old sediments that might have had a lot of organic matter in them from agriculture or forest clearing. And then if there's no oxygen at the bottom of the lake, which will be indicated from the profiles that I take, which I'll show you in a minute, you can have phosphorus come out of that sediment and fuel algae potentially. So I know like Lake Iroquois has that issue called internal phosphorus loading. So it's a good way to separate out the samples from what we used to do, which was a hose depth integrated sample at twice the Secchi depth, which could be going all the way down to the bottom. This is the case of Lake Iroquois. It's not that deep, but it does thermally stratify. So, now we can see there's a lot more algae growth near the bottom of the lake than there is at the surface of the lake. So the lighter blue here is that epilimnetic surface sample, and the black is the deeper hypolimnetic sample. And that's reflected again in the total phosphorus. So you see phosphorus actually increasing along with the chlorophyll throughout the summer because more phosphorus is being released from the sediment where there's no oxygen down there. Whereas the surface concentrations remain pretty low and pretty good, more in the kind of mesotrophic range, which reflected more of the Secchi depth monitoring. So that's another way to kind of line up what we're seeing in the different layers of the lake with the actual Secchi clarity. And then finally, caffeine, like Iroquois is one of the handful of lakes that actually had some caffeine results above detection. And that did actually happen right around that July sample when we had the flooding. So it could have been from that potentially, but something to start keeping track of. And the idea would be to use it as a outreach tool for seeing some results above detection for lake associations or towns to maybe use that data to encourage more septic inspections, also emptying septic systems, upgrading them as possible. For the next page of the lay monitoring report, I should have pointed out before, but down here there's sometimes 2 or 3 pages. Really, it's the first 2 pages going to have most of the information on them. The second page is for looking at annual means for each year, and this table here is kind of the old table, which is 1979 to 2022, using the old protocols. So that's where we're using the hose sample, this watering column sample, and really need to separate out that information from the new protocols, but still having it here to compare it to. And there's also at the bottom of the table here, I put in the Vermont water quality standard for most lakes in the state, which are considered class B2 lakes. but they also need to be over 20 acres for the water quality standard to apply. So it has a phosphorus value of 18 micrograms per liter, chlorophyll 7 micrograms per liter, and the Secchi depth of 2.6 meters. And that was part of the issue from the old data collection. You know, it looks like the phosphorus here is above the standard, but and same with the chlorophyll at times, but the Secchi depth is above, it's meeting the standard. And that again is because of the epilummetic versus the hypolummetic concentrations being different. So now when we look at the new annual means from 2023 onwards, we can separate that out over here. And there's also a column for metalummetic samples, which is the layer in between. For maybe a handful of lakes that might be doing that depending on their budget constraints. But again, so you can see these higher hypolummetic values for chlorophyll as well as for phosphorus. But looking at the epilummetic values, they're actually not so bad in the meeting standards, which is what we hope to see. And then, yeah, going through the summer annual means figures. So we just started that, the new protocols in 2023. So we're going to have a couple data points here, but we'll be keeping track of this for trends over time and also like scorecard. And we haven't seen too much of a difference here for Iroquois, which is good at the moment, but it's only a couple sample points and just really one for the caffeine sampling because of the new lab detection limit. And the next reports that I think are really cool now that I've done some updating to reflect the new protocols are these comparison reports or summary reports for each parameter. So at the top, you have a little description of the parameter itself and what it means. And then the first graph is actually just kind of a repeat of what's in the late monitoring report for that specific year. And also note that if you do see a B here, that means that the Secchi disk was hitting the bottom. So it's not necessarily a true Secchi clarity, but it just means that you can see all the way to the bottom. This is, again, with and without the view scope. And then the next graph here, which I think is pretty cool, is this historical graph. So it's looking at all the data ever collected for that parameter on this lake, going back to basically 1979. But it separates it out again for the actual collection method. So, before 2022 or 2021 or so was, all Secchi depth without a view scope. And now you can see the new view scope in here. And then the bottom graph, I think it's probably the coolest. It's kind of the summer averages for all the lakes in the lake monitoring program. So you can actually compare your lake to other lakes, which is kind of a good way to assess your lake really and how it's doing in the state. And I have it lined up in order of lowest Secchi depth, in this case, to highest Secchi depth, with and without view scope. So the lakes on the very right here weren't using a view scope for one reason or another. Either they were very shallow, or someone was trying to do it out of a large boat or actually a kayak where it could be really difficult, but still keeping those in order over here. And then the background of the graph here, and this is starting from the surface 0 to 10 meters depth going down. And I have the color-coded backgrounds for the trophic state, which I think most of you are probably familiar with, but oligotrophic at the bottom here being the clearest deep water, lowest nutrient lakes in the state, which makes sense that they're, lakes like Willoughby, Caspian, even Bombazine here has some great clarity. And then mesotrophic is kind of the intermediate range of clarity and, nutrient levels. Eutrophic being, high nutrients, typically shallower lakes. And those lakes, we see like Shelburne Pond is actually hypereutrophic. So it's kind of really extreme trophic conditions. It's pretty shallow with full of nutrients and algae blooms all year round, or all summer, I should say. Lake Carmine is kind of in that eutrophic range as well. A little bit of Champlain in there. And so Iroquois here is highlighted in green and it's kind of in the mesotrophic, almost oligotrophic range, but it's pretty much a mesotrophic lake, except for at the very bottom there where it's has that phosphorus internal loading from the sediment. So looking at the phosphorus summary report, same idea here at the top. It has the description of phosphorus and what it means, the 2024 results, and then the historical information down here. And this is pretty cool because you can see the difference in collection methods. So as I mentioned before, we used to use a water column hose sample at twice the Secchi depth, and that's in red. So you can see all those samples and the variation from year to year, but now comparing that to separating out the epilimnetic samples versus the hypolimnetic samples, which you can see are quite different. And then the summer averages, we're going from here, the lowest concentrations to the highest concentrations. And Iroquois here in green is again in the middle, kind of lines up with the Secchi clarity a lot more now. So it's a mesotrophic kind of range of phosphorus. Our oligotrophic lakes kind of make sense again, Maidstone, Willoughby, Crystal Lake. And then you have your eutrophic lakes, which again are like Carmi, some of Lake Champlain sections, and then hyper-eutrophic is really Shelburne Ponds. Those are quite high numbers over here, so you get to kind of see what the range is. And I should have mentioned, yeah, so I broke this out now into epilimnetic summer averages, and then hypolimnetic summer averages too, so you can kind of see the difference. And now Iroquois is actually in that eutrophic range in the hypolimnian. So it kind of makes a bit more sense now what we were seeing in the hose samples previously. And this is just a subset of the lakes that are actually doing this hypolimnetic sampling. But again, I wanted to focus on the lakes that I knew had some internal phosphorus loading from the sediment. Carmi's in there again. You have lakes like Valley Lake, which is interesting, quite high numbers in the hypereutrophic range, but it has some of the best clarities in the state because it depends on the shape and depth of the lake. And so Valley Lake it's a pretty small lake, but quite deep and has really a deep hole. And that hole becomes kind of anoxic, or there's no oxygen down there. And that's where you get these high phosphorus release from the sediment, but it really stays trapped in that hole, potentially even over the winter. It might not fully mix. And that's really why we're seeing these really high numbers, and why it was important to separate out the hypolimnic versus the concentrations, which for Valley Lake are quite low, definitely more oligotrophic. And again, down these other lakes, it's good to have some comparisons for lakes like Lake Willoughby and Maidstone, where we don't have internal phosphorus floating. So we wouldn't expect to see higher concentrations in the hypolimnian, and we don't. They're oligotrophic, same as Shadow Lake, Glover, Echo, quite a few here doing really well, Cascade. And that's what we would expect to see. I'll point out Lake Morey too, which did have much higher phosphorus concentrations in the hypolimnian previous to this year, where we did the alum treatment to basically secure or inactivate that phosphorus in the sediment. And so those are the results that we're seeing now, are in the kind of almost oligotrophic but mesotrophic range, which is really great to see. And the next one is chlorophyll summary. So again, description at the top, 2024 data at the top, and then historical comparisons to the old water column hose versus now the epilimnetic and hypolimnetic results. Epilimnetic averages, Iroquois again in the mesotrophic range, which makes a bit more sense with its Secchi depth. Shelburne Pond again being hypereutrophic, Carmi eutrophic, and then our oligotrophic, very deep Clearwater lakes down here at the left end of the scale, which is what you'd expect to see. And then for the hypolimnetic concentrations, again, Iroquois shoots up into the eutrophic range, so we know there's that internal phosphorus loading going on there, fueling some algae, so something to keep an eye on for potential blooms in the future, and especially during the fall mixing period, when you can have a lot of that phosphorus come up to the surface. But hopefully by then the temperatures are colder, so you don't get the big blooms you might see in the summertime, like in a Lake Carmi, that can kind of get easily mixed. And yeah, so Shelburne's kind of up there again, which is what you'd expect to see. But again, you get some of these other lakes that have deep holes, like a Fern Lake. It's a very clear lake just south of Lake Dunmore. Not much going on in the watershed there, but it has a very deep hole that probably stays anoxic most of the year. And you can get some interesting types of cyanobacteria and other algae that can grow in those deep holes, but it really stays locked down there for the most part until potentially the fall mixing period. And then again, the really clear deep lakes at the left end of the scale here, you're not seeing much algal growth deep down. And I should mention that, yep, go ahead.
Yeah, sorry, I had Jackie again. There's a question that I thought might be pertinent at this time from
Sure.
Arlene from Fairleigh. She said, I have a question about the caffeine level. Can you relate the value to maybe some other quantity like number of septic tanks? Lake Maury also has one date, 714, where it's above the detection limit like Lake Iroquois.
Yeah, great question. So I'll just head right into the caffeine summary reports.
And
And
then
this is where I think we,
Steve Walsh from Lake Eden said that detection level was changed for 2024. Why would that be? And is there a level of acceptable caffeine?
so to answer the first question is it was changed in 2024 because the lab was able to, they just started doing that testing in 2023. Because once I found out they were able to do that testing and that they were actually doing it for some agricultural samples before that, they were also using it as sort of a tracer for agriculture to see if there's any human wastewater getting into some of their results. So then I asked the lab that, oh, can we actually just pull that test out to start doing for lakes on a statewide scale, to keep it cost effective. So their first year when they went through it, they had to actually develop the separate method and to keep the cost at about $30 a sample. So that's when it was 0.5 micrograms per liter. And then when I said that, we didn't really get that many results that were reported, they actually had like quite a few detections, around 60, that they couldn't report out on because of the actual detection reporting limit, was too high. So they went back and were able to refine their methods to get down to 0.1 micrograms per liter to be able to report those detections. And sure enough, I got about actually almost 70 total detections this year, which is close to the same number of detections the previous year that they couldn't report out on. So that's why that change happened, which I think is a good thing because, the lower detections, the better, so that we really shouldn't expect to find any caffeine especially in our lakes. I mean, some of these lakes are quite big lakes with lots of water, could be flushing out fairly frequently as well. And really, again, the only source is from human wastewater for our lakes, potentially people dumping coffee grounds in, but again, that's still wastewater. And so, if we do detect any kind of caffeine, it really is a decent indication that there's probably some outdated septic systems or even failing septic systems that are allowing the caffeine as well as other potential contaminants to get into the water, including phosphorus, but also pharmaceuticals, things like that. So well-functioning modern septic system should remove pretty much all the caffeine. You really shouldn't be able to detect any by the time it gets from your groundwater into the lake itself. So that's the idea behind that. And this is the summary results for caffeine. I give a little background up here, information, and then for Iroquois again, it's historical. We just started doing that. And then this is the comparison graph. So I think this is where it gets kind of more interesting because just about every lake we were monitoring took caffeine samples this year, and only about a third of them actually had results above the detection reporting limit. And about half of those, about 15, only had maybe one result. So we do want to wait a few more years for more data to see if there's consistency. There's always potential for contamination as well. If you're not keeping your hands clean, you're handling the sample and you just had coffee or grinding your coffee, that's potential for contamination. So we do want to be careful with that. I collect caffeine samples when I'm out there, and I've had some also, I've gotten some detections in some of the same lakes that the volunteers found detections. So, that's kind of confirming that I think it is something real that we're seeing. Most of these lakes that do have detections kind of makes sense. I mean, we have a lot of camps. We have a lot of old camps on lakes around the state. So then the ones that haven't had many camps or not very well developed are the lakes that we haven't seen any detections. So that's kind of another confirmation. So Iroquois here had the one detection, and I think it was Fairleigh. Did we see a detection? I forget. So there's that's the epilometic. The hypolemmatic is even less amount of results, but we see some repeats here. I was going to mention Mirror and Forest Lake, which are actually connected. That's kind of interesting. Maury, yes, did have a detection, and I was sampling Maury actually on a biweekly basis myself over the past year because of the alum treatment, and I had a couple detections as well. One was on, I think, the same day as the volunteer result. So yeah, something that we're seeing, and I mean, in some ways, I'm kind of excited about it because it's fairly novel monitoring study that we're doing on a statewide basis using a volunteer program to do this many lakes. I don't think it's really been done before. I know other states in our region are interested in these kind of results. EPA as well. EPA does do caffeine monitoring typically when they find E. coli exceedances in rivers, which they're doing more in like urban areas, and they'll use caffeine as a kind of an indicator that it's probably coming from human wastewater. So it does have that implication there. And yeah, Carmine was another one that kind of showed up in a few samples. So there was a group of lakes that had multiple results. Dunmore was in there too, so that was a little concerning to me. But there's a lot of shoreline development around Dunmore, a lot of camps, a lot of old camps. Waterbury Reservoir is interesting, that had multiple hits. It's a huge watershed draining some urban drainage down from Stowe and other places. And the flood could potentially have increased those results as well, which again is why I would like to get multiple years of data before saying too much about this. But potentially looking at the timing of when we're seeing those results, which quite a few were in that July time period, could be from the flooding that we're seeing as well.
Mark, I have two more comments.
Sure.
From Jim Bennett. He said, on the subject of caffeine, if lakes are getting negligible levels in their samples, will we suspend future testing in that lake? And the second one, oh, go ahead. You can answer it.
Yeah, I'll answer that one first. That's a great question, especially because of the budget constraints that I've mentioned before with the parameters. I mean, the good thing is since caffeine is a new parameter we're sampling, the cost that they just set, they're not increasing that. So it's still at $30 a sample, which is now cheap. Chlorophyll used to be $30 a sample, and now it's actually above 90, I think. So it's tripled in cost. Phosphorus has doubled from about $12 to $25 or so. So it's something that I do have to take into consideration. So yeah, I potentially might drop out lakes that we haven't seen any results from in the future, just to save on budget costs. But at the same time, it's something just like other parameters. It'd be nice to kind of continue to monitor to see if we do see changes in the future, from development or things like that, and also to have comparisons. It's always good to have lakes that don't have high results to compare to the ones that do, just so we know that it makes sense what we're actually monitoring. What was the next question?
Yeah, is there a special scenario happening at Lake Iroquois, or is it just the lake selected for example purposes? Wondering why it is green when you highlighted the scale.
Yes. Yeah. So I use it as for an example purposes because it had kind of results everywhere. Detectable results in caffeine as well as chloride, which I'm about to show. Yes, the green is the lake specific report. So these are all lake specific. So when you go to the lake monitoring webpage report section, you have for each lake, it'll have like a phosphorus comparison, chlorophyll comparison. So when you click on that, it goes to the specific lake, so you can see that lake highlighted, as well as the annual reports and the historical data here. So it is lake specific, yes. So finally, chloride.
I have another question. Sorry. Steve Welsh asked, Mark, on these charts, is it possible to put the Vermont standard or desired levels for each category? It would help for those of us that aren't as in tune if we could compare what we are observing compared to where we should be.
Yeah, so that's a great question I mentioned earlier. I'll just quickly go back to where I do have those standards. And there's a link to the actual water quality standards themselves. You can find that information. But here's where I had the standard at the moment. And the reason I haven't really incorporated it into the new annual data, because it is based off of annual data. And it's also when we're doing assessments for the EPA reporting, we're looking at the previous 10 years of data. There's a assessment and lifting methodology that goes along with the water quality standards. And we don't have 10 years of data yet with the new protocols, other than the lakes, the shallow lakes that we're always doing surface epidemic sampling. Those are the ones that I can assess the previous data using the current water quality standards. But those water quality standards are based on the twice the Secchi depth sampling or the hose sampling for the deeper lakes. So that's why I'm I'm working on recalculating actually some of our water quality standards to reflect the new protocols. So the epigenetic sampling basically. Um, and when we have those numbers, I can kind of put them right on this figure here, because really you're looking at the annual data to compare to the actual water quality standards. So hopefully that answers the question there. In the summary figures, again, I hesitate to put any standard in here because of the protocols, but also because not every lake, well, first of all, it only applies to lakes that are at least 20 acres, which there's a few in here that are a bit smaller than that. There's also some ponds that are kind of more wetland-like, so we wouldn't necessarily apply the same standards to. So we kind of use this trophic state to kind of show the differences, and it's really looking at the extremes, right? So the really eutrophic lakes are the ones that we're kind of focusing on that make sense, that are impaired already, like Shelburne Pond, South Bay, and again, like Little Hosmer's in here, but that's actually it's just the sort of natural influences, so we wouldn't consider that impaired. So that answers the question there. Just getting to chloride, which is the final thing. I just added this because it's not something that volunteers normally collect. It's something that I collect, and I wanted to report out on it and get a lot of questions about road salts. It's something that we are getting more and more concerned about. Even the legislature is finally talking a bit more about how to deal with the chloride issue from road salts, how to reduce the amount of road salt use, educate applicators. So, you'll see probably just like one, if I visited the lake that year, it would just be probably one sample, both from the epigenetic and the hypoluminetic, which typically you don't see much of a difference between these. Chloride's pretty well mixed in the lake systems. And Iroquois here has fairly high numbers. So 2 milligrams per liter is the detection limit, and most of our lakes in the state are below that. It would be kind of the natural background. So this is definitely one of the higher end. And we have collected these chloride samples in the past. Here you don't really see an increasing trend, although it's only been about 5 years. But other lakes we have started seeing that. Lake Maury is another example where we have seen some increases. And Iroquois is kind of on the higher end of, for lakes. And these numbers are not, we do have a chloride standard, but it's like in the hundreds, and that's for chronic or acute conditions. There's 2 different standards. And we have some streams in the state that have been impaired recently for chloride after doing enough monitoring. So they are doing some remediation management in some of those streams. And they're mostly like urban streams in like Colchester, Burlington, or Rutland. But of course, they're flowing into lakes, at least Lake Champlain, which have definitely seen increases. I think Champlain is now approaching around 20 milligrams per liter. And I think there's efforts and there's studies going around the country, as well as other countries, most likely, about toxicity effects of chloride on the aquatic biota, and how actually their lakes could be even more sensitive, and potentially lowering some of those standards to, more around maybe like 40 to 50 milligrams per liter. So Lake Champlain is doing a bit of work on that. So stay tuned, but it's something that we need to keep tracking. And, if it keeps going up, that's going to be an issue in the future for sure. So you can kind of see the comparison of lakes here. Not too surprising. Shelburne Pond is the highest one, and it's not too surprising because some of the tributaries are quite high in chloride. Waterbury, again, a big watershed draining in some Champlain sections here. So, and then even some of our, larger, deeper lakes, Willoughby, Echo, something to be aware of. And Willoughby, we're doing tributary monitoring there as well. There's one that has really high chloride, even though it's not a big tributary, but it's probably where some of the concentrations are coming from. Hypoluminetic samples, like I said, they're quite similar, so you really don't see much of a change in these figures. But it's kind of another confirmation that those samples are good, those results.
Mark, I have another
Sure.
comment from Arlene Guest. It would be nice to be able to get data in spring and fall, especially chloride. We have a fall cyanobacteria bloom, including this past fall, in Lake Maury, as detected by satellite remote sensing and verified by site.
Yep. Yeah. So Lake Maury, especially, we are doing quite a bit more monitoring there. Actually, me specifically. So I start monitoring there in the spring, kind of May, through October, through sort of the fall. You're a mixing period there, and I do have that data that's actually in the presentation that I gave, and I put a link to that presentation on the lake monitoring reports web page section. So you can kind of look at that data, and then also at the very end here, I'll show you the data portals where you can access all the data, the actual raw data that we collect, and it'll show you know the different dates. Including the spring monitoring program that we do have. And that's, again, that's a bit separate from this program. I think I've shown spring data in the past here. Let me just go back real quick. In the lake monitoring reports, they do include spring data here, at least in the past, which is done sporadically. So this is kind of an average, but you can find that in our data portals as well, if there was spring monitoring done.
And another question from Julia Crocker is, where does the chloride come from?
Yeah, chloride comes from, and again, that's in the lake monitoring program webpage and also the summary reports. But the main source here in Vermont is going to be the road de-icing, so road salts. So it's sodium chloride. So chloride's obviously the part of that molecule that we can easily monitor and detect. I mean, it's actually probably the cheapest. It is the cheapest parameter that we can monitor. But other states are doing a lot of work on it, like New York, New Hampshire. So yeah, but it's also it can come from other things. I mean, it's naturally in groundwater, but again, at very low levels typically. You know, in Lake Mooring, we see really high concentrations from the streams draining off of I-91, so we know that's from road salt use for sure. But also a lot of these local roads around directly around our lakes, and also for anti-dusting. So, and I've seen these trucks drive around in the summer. They're spraying chloride onto the dirt roads to actually, it just keeps the dirt more on the road than turning into dust. And then also in water softeners can have salts, you know, that they use, so that could actually be coming through septic systems into our lakes. That's another source. But really, it's road salts are thought to be the biggest source.
And I have a couple more here, Mark.
Yep.
What is the current explanation for increasing phosphorus levels in many northern Vermont oligotrophic lakes?
Yeah, I mean, that's an interesting question as well, because some of those trends, and again, this is Lake Scorecard, which we're showing those trends through 2022, and you would see those in this kind of these figures here. But we showed spring phosphorus monitoring, so a lot of those trends come from that. And you have to be a little bit careful with spring phosphorus data because it can be pretty sporadic. So it's not a consistent program really from year to year, which is really how you want to do trends over time. But sometimes it's the best information that we have, and it's just a one-off sample in the spring after the ice out. So that can be really weather dependent. You know, if it was a very rainy spring, or you know, there was just a lot of runoff going on, or some storm events. We get a lot higher phosphorus during those times, and then also their sampling methodology has changed a little bit over time too. So we have to be a bit careful there. But if you see in the summer data, that could also be potentially from those those hose samples that I mentioned. That could have been picking up like phosphorus, deeper down, and it's dynamic because it's twice the Secchi depth those hose samples were, so it's not always the same depth. So it's a little bit of be careful analyzing that data. We don't see that much with the Secchi or the chlorophyll, which can have a lot of variation to it. So it's another reason why I actually changed the protocols to now we can start detecting the surface conditions versus the deeper conditions, which can be affected by internal loading, internal phosphorus loading, or other types of like algae, cyanobacteria further down in the lake. But if those trends were actually real, then the next question is why? And a lot of the reason, most likely from these oligotrophic lakes, it's probably climate change related. Sorry, so it's the floods that we're seeing, and we just saw that in the last couple of years. Some of the oligotrophic lakes, Caspian, Echo, Seymour, Clarity's dropped dramatically after the floods. So even though there's a really large, deep, clear lakes, we're getting a lot of sediment from those storms, and a lot of it's coming from roads, culverts, blowing out, like on Echo Lake. So you can see that, but the sediment typically does flush through quite quickly within the same summer. A lot of it will probably settle down to the lake bottom, which could be a problem in the future, potentially as a source of phosphorus, but a lot of it also just gets flushed out through the outlet. So sometimes we pick that up with the samples, the deeper samples, especially because the sediment kind of sinks down. So that's probably likely the cause if we were seeing increases there. But again, you have to be careful of the actual sampling protocols that you're seeing.
Mark, it's 1 o'clock.
Yeah.
We're happy to keep going, and if people have more questions and you have time, but I just want to let you know it's 1 o'clock.
Yeah, I appreciate that. And I'm glad to have the questions as we were going. I'm just about finished here.
Okay.
I'm just kind of breeze through the lake scorecard, but the last few things I wanted to show are these additional kind of graphs that I put out there for my, lake visits. So this is an lake visit I did at Lake Iroquois over the last summer, and this is showing the vertical water quality profile for dissolved oxygen and temperature, which is really important to see that thermal stratification, which is the green triangles here. Warm water on the top, colder water on the bottom, depth on the y-axis here. And where we have these lakes that have the internal phosphorus loading, it's because you don't have any oxygen at the very bottom. So for Lake Maury, it's plenty of oxygen, 100% at the top. At the bottom, it goes to 0 at 8 meters, which is where we're doing the sampling here to indicate the phosphorus coming from the sediment itself. That's mostly from legacy land use, like I said in the past, where there was resorts like on Lake Maury that had raw sewage going into the lake, or land clearing, and a lot of our lake watersheds that had a lot of sediment come down, and of course like septic systems, things like that. And then I also do show tributary results. This is one form, but we also have some other automated graphs now. It's just like a list of all the different tributaries and showing the comparison of phosphorus values. So Iroquois does still have some tributary sites with higher phosphorus, as well as the chloride, which makes sense that we're seeing higher chloride in that lake. There's some tributaries with high values there. And then finally, just the portals that I was mentioning. If you want the raw data to look at everything that's collected on our lake sites throughout the year with all the different monitoring programs, that would be this IWIS data portal here that you just type into the lake, search the site, look for the different station that you want to see, usually station 1. The lake monitoring data portal I finally have updated. I realized people are still using this. It was a little outdated. Now I've updated it with the different protocols, so you kind of separates out the data a bit better, so you can actually just get the specific data for your lake for lake monitoring that way. And then finally, lakeshore land use and cover maps, which are pretty cool to see. Things like septic systems that make sense with the development of that lake that we're seeing caffeine kind of look a bit further into, or, agricultural land use, things like that, where we have more phosphorus, higher phosphorus concentrations. And then finally, the other monitoring resources for cyanobacteria monitoring, for E. coli, if you're interested, that's done through the Department of Health. And then there's invasive plants. There's different programs for that as well. And also additional information down here, which is pretty cool. If you see different stuff in your lake, Maine has a nice guide to kind of visual observations of what that might be in the lake. And I'll leave it at that. I'm still available for questions if anybody else wants to stay and chat.
I have one more, but Martha, I just wanted to ask if he answered the question that you would put in about the significant flooding and the differences. I'll just read it. The past 2 summers, we had significant flooding events at our pond, as many did. I expected to see much higher levels of phosphorus and late season chlorophyll. Were there higher numbers at the statewide level, or was it only around the flooding date? That's from Martha Winston.
Yeah, so I think what we saw, in quite a few lakes where the storms are really intense, it was the drop in Secchi clarity quite dramatically. And a lot of times you would see a delayed effect you might see an increase in phosphorus kind of right away, depending on, again, in that sediment. Most of it was kind of like sediment that might sink down. So you might capture that in the hypolimitic sample. We saw some spikes there. But with the chlorophyll, you would typically see potentially a delayed effect, because with the reduction in clarity, you actually reduce the amount of light available for algae to grow. So you're going to have higher phosphorus, and also because that phosphorus is in sediment form, it's not necessarily readily available for algae to take up. You might even see a drop in the algae or the chlorophyll levels after the flooding, but then potentially a rebound and an increase later in the season when the clarity is kind of lakes would clear up again, and then phosphorus would become more available for algae to grow. Especially potentially in Lake Champlain, although there's a lot of factors in Lake Champlain that kind of determine the algal blooms. But like a Lake Carmel, I think was a good example of that too. Flooding in the last couple of years probably actually delayed some of the algal blooms, but then we definitely still saw them later on.
And Chris Owen asked how accurate are the lake depth charts? This is important given the wake boat rule and his 20-foot depth limit.
The new depth charts are quite accurate. I'll show you real quick. And we do use those, and there is maps specifically for the wake sports zones that have been produced that I think you can find probably already. But yeah, those contours, I mean, probably just show you a quick one here. Are quite important, and I'll go down to Maury as an example. And I hope to get, most of the lakes in the state updated at some point, but if you do have to pay for a subscription to do this kind of sonar mapping, and having the staff capacity to do it is sometimes limited, but these are quite detailed maps, and you can see like the deepest sections here. And really the sort of set 20-foot contour that we're using for the wake sports zone at the moment. So that's how that mapping was done from these actual maps, and then finding the 20-foot contour and kind of making that area as the potential area for wake sport zones.
Mark, is it okay if I ask a question? This is Sean Tierney, Nelson Pond.
Sure.
I had a question about the watershed action plans.
Yep.
I know that you said that 15 lakes in Vermont had that. Is that something that we should be working on for all our lakes? And do we have a template that we could use to start working on that?
Yeah, so I just I provided the links on the lake monitoring webpage to this Lake Watershed Action Plans webpage. So I would recommend going there. And there is like a guide, I believe, to kind of how these plans work. But as far as the funding goes, I mean, it's a limited amount of funding to do these Lake Watershed Action Plans. The DEC has typically like maybe $50,000 to $100,000 a year. It's not guaranteed every year to do these plans, mostly outside of the Lake Champlain Basin, as well as the Memphremagog Basin, because there's already money kind of going in to do projects there. Although we have gone within those basins too to do action plans where there was a big need. So it's a prioritization process that we're usually looking at lakes with either increasing phosphorus concentrations, or that we know have or decreasing clarity, or that there is land use in the watershed that is probably affecting the lakes. So agricultural land use, or there's forestry, roads, because that's one of the big issues. And then as well as shoreland developments, that there's a lot of lakeshore development that could use Lakewise, for instance, and that's a big part of the Lake Watershed Action Plans. And it's just a way to kind of funnel some money to do more comprehensive studies, and we contract out. A lot of times it's water service providers or the natural resource conservation districts do a lot of work, especially in the Northeast Kingdom, to help do these studies. Yeah.
Yeah. My thing was.
I was just going to add. Let me just add. So we did a entire hour on watershed action plans. It's on our website. You can watch that. And this series is actually part of watershed action plans. So the first one talked a little bit about, kind of getting watershed action plans off the ground. And I was going to say the next one, number 3, which is on March 6th, is going to be sort of how to get your partners and collaborators together to begin a watershed action plan. So we are we have a lot of information, and you can drop me an email
And-
and, you know, our emails are on the on our website, and, I can sort of direct you to a lot of the information. And the ones that are done, which are on the DEC website, so you can kind of get an idea of what other lakes have done and where their funding is coming from, but,
Excellent.
yeah.
Okay,
yeah.
thank you.
So we're trying to do this to get that word out to lakes that haven't done it yet. So.
And
anyway.
Allison put her email in the chat box. If you could
Oh,
see that,
perfect.
and get her email for any questions that you have.
Yeah,
and-
definitely feel free to reach out to me if people have questions about their specific lakes or anything like that.
Great, Allison. I didn't realize you were on. So
I'm here.
Allison is the leader on this, at DEC, Allison Marchione. So, yeah. And she did the presentation that's on our website, that sort of walks you through the whole process.
And I also just mentioned that Lake Champlain Basin Program funds
Yes,
Somebody-
Okay, thank you very much.
action plans too.
yes, yeah.
A little bit different, but yeah, same idea.
Are there other questions? Jackie, is there anything else in the chat?
No, some great thank yous that was very helpful to Mark from Jim and Arlene and
Oh, I
Teresa.
just saw, there's a comment from Dave there I just saw.
There it is. That's done. With the new requirement encouraging composting of food waste, many now compost coffee grounds. Can surface runoff of caffeine from composting confound the assumption that detected caffeine comes from septic systems? That's a lot of C words, Dave. Thank you.
Yeah, it's funny. I've gotten that question before, as well as the one of like, people peeing directly in the lake. But of course, that would still be a human caused input and wastewater to some degree or another. So then it would mean that your garden is contributing to some of the runoff in the lake, or however you're disposing of your compost. So yes, it wouldn't necessarily be directly from the septic, but it would still indicate kind of an issue of wastewater anyways. But I would still say that the septic systems would still probably be the largest source of caffeine overall, than whether it's people peeing directly in a lake or spreading out their coffee grounds. Because yeah, there's a lot of different food items that we also consume for that have caffeine in them as well. So yeah.
Okay, any other questions? Jackie, everything? Okay. Thank you, Mark. This is great. Having all that data available is fabulous, and it'll be super helpful, I think, for everyone as they work on their various management plans and figuring out what's going on with their lakes and being able to compare them. It's great. I also want to thank the events committee for putting this and all of our webinars and other events together. Special shout out to Dave Johnson and Deborah Muccio. Also Jan Parsons, Jerry Bergdahl, Laura DeLugalecki, and of course, to our intrepid and amazing Jackie Sprague, who chairs the committee, is also our vice president, who is monitoring the chat today. So I appreciate all of that. As I mentioned, mark your calendars for March 6th. That is our next webinar in this series, and we'll be talking about how to get collaborators as you get your watershed action plan off the ground. So this is sort of the beginning of it, creating those partnerships and collaborations. And once again, thank you, Mark. I think that this information will be really helpful for people beginning their watershed action plans, and certainly for those lakes that already have them, but as they begin to monitor the projects that come out of that watershed action plans and be able to compare, hopefully seeing improvements and all those data points. So I really appreciate that. All right, so we are going to adjourn. Just a reminder, as you leave the meeting, a survey will pop up, very, very brief. So we ask you to take just a minute to fill that out. It really helps us as we create more of these events. So once again, thank you, everybody. Appreciate it.
Mark.
Thank you, Mark. Appreciate it. Bye.
Thank you, everyone. Bye.